Hello everyone, I'm Martinus Bagus Wijaksono, and today I'm gonna share a presentation entitled Design of a Fuzzy Logic Controller using 9x9 metric triangular membership function. So, fuzzy logic control is a powerful technique for optimizing system performance. In FLC, membership functions are used to represent linguistic variables. This presentation explores how to design the 9x9 metric triangular membership function to enhance FLC performance using MATLAB. Here, fuzzy logic control is a methodology that mimics human decision-making processes by using linguistic variables and fuzzy sets. It allows for imprecise and uncertain information to be used in control systems, enabling more flexible and robust control. So FLC has been successfully applied in various fields, including robotic, automotive system, and also industrial automation. The membership function defines the degree of membership in an element in a fuzzy set. In FLC, triangular membership functions are commonly used due to their simplicity and effectiveness. A 9x9 metric triangular membership function provides a finer and more precise representation of linguistic variables, allowing for better control system performance. So here are the advantages of fuzzy logic control. The first one is easy to understand and implement. So FLC uses simple linguistic rules such as if, then. This makes it easy to understand and apply even by people who are not experts in control theory. And the second is tolerant of uncertainty. So FLC can handle uncertainty and variability input data. This allows the system to make a decision based on uncertain or ambiguous information, similar to how humans make decisions. And the third one is flexibility. So here, you can easily customize FLC control rules for specific application needs. This makes it suitable for many types of systems. And then the next advantage is smooth response. So FLC produces smooth responses to changes in input. This means that when the input variable changes slightly, the output doesn't jump as drastically, resulting in smoother performance. And the last is the adaptability. So here FLC can be taught to adapt to environment or system changes. This can be useful in situations where system parameters change over time. And the next is the disadvantages. So there are some disadvantages in using FLC. First one is requires experimentation. And then the next is requirement of good data input. And the third is only suitable for some application. So here FLC sometimes is ideal for all systems. In some situations, other control methods such as PID may be more appropriate. And the disadvantages number 4 is heavier computing. So FLC processing is typically more intensive than other control methods, such as PID control. This process can be problematic on devices with limited resources. And the last is difficulty in modeling complex systems. Next is the designing fuzzy logic controller using MATLAB. So here we have two input and one output. So the membership is about 9 variables here. These are the variables. First is TL, too low, and then NL, negative large, and M, negative medium, and S, negative small, AZ, approximately 0, PS, positive small, PM, positive medium, PL, positive large, and PH, too high. And this is the value of those all variables, starting from minus 60 until plus 60. And since we have 9 variables, so it will be like 9 by 9 matrix. Here, to create the membership function, I use the membership function based on the journal entitled Automatic Generation Control of an Interconnected Hydrothermal System using Conventional Integral and Fuzzy Logic Controller. Okay, next we can continue to the MATLAB directly. So first we have to open MATLAB, and then after that we can type fuzzy here and hit enter, and we will have Fuzzy Logic Designer. The default is one input and one output. So here we can add more input here. After we have two inputs, then we can continue to set the membership function of our input. So here we have to set those all 9 membership function in the first input, second input, and also the output. So I have set those all membership function, so we can import from file here. This is my membership function. This is the input 1, and then this is the input 2, and also output 1. So after we finish with this kind of input, then we can continue to set the rule editor. Here, since we use a 9 by 9 membership function, then we will have about 81 rule editor here. And then after we finish with this setting of rule editor, then we can see the surface. We can click view here to see the surface of our rule editor. And also we can see the rule here. Okay, this is the rule viewer. So basically, if we set the first input by shifting this red line, this is the setting of the input 1 value, and then this is the setting of the second input 2 value. After that, we will have the output here. Okay, after we finish with the setting, then we can go to the Simulink. And here we can click Simulink and then open blank model here. And then we can go to library browser and find the fuzzy logic controller. Just drag and drop here, and then for the display we can find the display in the library, and then drag the display to our Simulink. Next, we can also put the scope as well to show the graphic of our output. And then for the input, we can put the sine wave. Sine wave function here. Oh, sorry. Sine wave here. And also constant as the input. And to combine these two input, we need a mux. We can just drag and drop here. Okay. After that, from our Fuzzy Logic Designer, we can save this Fuzzy Logic Designer by clicking File, Export to File. And then this is my Fuzzy Logic Designer file. I have saved it already, and we can call the Fuzzy Logic file. Double click the Fuzzy Logic controller here, and then type the file that we have saved before. I will use this fuzzy. Let me check first. Yes. Okay. Next, we can set the amplitude value in our sine wave. I will put here 50, and then the frequency maybe I will change to 1.5, and then for the constant I will put 5 here, and we can run to get the result. Okay, this is the result of our system. 35.85, and if we double click the scope here, then it will create the graphic of our output here. And if we change the stop time here into infinity, then we will have our graphic here is moving. Run. So this is the graphic that we have, and then here is the value of our output. Okay, this is the end of my presentation. Thank you for your kind attention.